Compound interest is when the interest is applied to the amount that you put in initially, but then as you earn interest, you'll also get interest on the interest you've earned. So it compounds, it keeps adding on to itself in a way. So if we look at an example, Spencer wins the sweepstakes at work. He decides to put the $4,000 winnings into his savings account that has a compounded interest rate of 4.7 per annum. So this means they apply the interest once per year. If he leaves, annum being year, if he leaves the money in the account without withdrawing any, what will be the total amount he will have in his account after 5 years? There's a couple of things in here we need to pay attention to. The first thing is what we call the principal, or P, and that's the initial deposit. So in this case, P is going to be equal to 4,000. The next thing we might want to look at would be the rate. And this is the interest rate, and you want to think about converting it into decimal form. So here, our rate is equal to 4.7%. So divide by 100, you get 0.047. Remember, when you're using percentages with calculations, you always have to convert it to a decimal. Okay, so our rate's going to be 0.047. The next important thing for us is going to be t, or time. And this is the time the interest is compounded for. So here we're looking for 5 years. So t in this case is going to be 5 years. And with this kind of information we can take a look at solving it. So I'm just going to get rid of that so we have room. If we think about the first year, he has $4,000, and at the end of that year he'll have interest applied and he's going to get some amount. So if I think about this, I want to increase $4,000 by 0.047%. So I could go 0.047 and I'd get 188. And then I would say 4,000 plus 188 is equal to 4,188. And that's the amount at the end of year 1. That's one way to think about it, but I prefer to do these calculations in one step. So remembering that if I want to find an increase of 0.047% or 0.047 on that $4,000, when you're increasing, you can always go 1 plus the rate. So here I'm going to have just 4,000 times 1.047 is going to get me straight to that $4,188 at the end of the first year. So that's in year 1. And that idea that if we times by 1.047 at the end of every year, we're going to get our new amount. So now that after the first year in his bank account he's got $4,188, that'll sit there and then it will be increased again. So we apply that amount again, that same percentage, and the next year, at the end of the next year, he's going to have 4,384 cents in his account. And so much like we did before, that amount is going to go into the start of the third year, 4,384.84 cents times the compounded interest rate, and at the end of the third year, 4,590.92. And again, that amount will get compounded in the fourth year. So we can see what's happening here is that every year he's gaining more and more interest. And his account is growing and getting much stronger, much wealthier as time goes on. So at the end of the 5th year, let's see what he's got. 4,806.70 times an increase of 1.047, and we get to $5,032.61. So if he leaves his money in the account untouched for a total of 5 years, he's earning in interest $1,032. If you take off of 4,000 there, basically the amount he's gotten through interest is $1,032. That's quite good for just putting your money in an account and letting it sit there. So you can go through this year after year after year, doing it for each year, timesing it by the interest, taking the amount from the previous year, making that your new principal amount, and timesing by the interest rate. But there is a shortcut for it here. And it becomes a formula. So if you pay attention here, we've times by this, we've times by this again, times by that again, times by that again, times by that again. So we've done that 5 times, and we were looking for 5 years. Now that number that we've times by over and over and over again is 1 plus the rate, what we talked about here. So 1 plus the rate is 1.047 in this case. So our formula, if you want to think about A being the final amount, is going to be equal to the principal times 1 plus the rate to the power of t, the number of years. Write that. And I'll just do this. T is usually lowercase in the formula. Should have done it there as well. But t is the time. So if I want to know how much he'll have after 5 years, I could go through and do that every year 5 times in a row. Or I could get to the solution in one step by saying the principal, so the amount he'll have after 5 years is going to be equal to the principal, which is $4,000, his initial investment, times, bracket, 1 plus the rate, which was 0.047, to the power of 5 for 5 years. And if you want to, save yourself a step in the calculator. Think about just writing that 1 plus 0.47 all as one thing if you want. And if you do that in the calculator, you get straight to the $5,032.61 after 5 years. So again, this becomes our formula. The amount is equal to the principal, or the initial amount, times 1 plus the rate, the interest rate, as a decimal, all to the power for the number of years you've done it for. So if we took the same example when we said, okay, well, how much money does he have after 10 years? Let's figure that out. After 10 years, okay, same thing's going to apply. The principal was 4,000 that he put in, times 1 plus the rate, 0.047, to the power of 10 because it's 10 years. So when we do this in our calculator, we get $6,331.79. So over 10 years, he'll have made quite a lot of money. And if you wanted to know that, you know, how much has he earned in that time, you would go the 633 minus the 4,000 he originally put in. So he's earned $2,331.81 in 10 years by leaving his money in that savings account. So this is just another reason why it's important to start savings. You might feel you're too young to do it, but it's never too early to start. It will pay off for you in the long run if you have a decent interest rate. So again, here's your formula. The initial amount is equal to the principal times 1 plus r to the power of t. If you can't remember the formula or you blank out, just remember that process for how we do it. 4,000, increasing it by the rate, so it's going to be 1 plus the rate, and then just take that amount that you've earned each year and use it for the new year. And then again, take that amount, that new amount, and apply it to the next year. And again, and just keep doing that until you've done it for enough years that you've filled everything up. Or done as many as you need to, I should say. So either way, you can do it step by step, doing it year by year by year, or you can use the formula. Doesn't matter. As long as you show you're working clearly, you'll be alright.